In this circuit we need to find current I naught and voltage drop V naught. So we can see that there's a voltage source here, and if we want to find this current, what is the current here, let's call it I, we first need to find the equivalent resistance as seen from here. So 70 ohms and 30 ohms, these two are in parallel, so that will be 70 times 30 over 70 plus 30, which is 21 ohms. And then these two are in parallel, 20 and 5, so 20 times 5 over 20 plus 5, so that's 4. So the circuit reduces to this 21 ohms and 4 ohms, and here 200 volts. So this current I becomes I over 200 over these two are in series, so 21 plus 4, which is 25, so that's 8 amps. So that's the total current. Now we have to go back to the original circuit. I will redraw it here, and this one. So we have 70 ohms, 30 ohms and 20 ohms and 5 ohms here, and this is the current we want to find. So when 8 ohms comes here, 8 amps comes here, it has two parallel paths, one is 70 ohms and 30 ohms. So we will just see how these 8 ohms split between the two paths. So that's what we have to, how it splits between 70 ohms and 30 ohms. So this current I70, if we say, that will be 8 over 70 plus 30 times 30, which is 2.4 ultimately. So 240 over 100, so that's 2.4 amps. So that is this current, 2.4 amps. And the other current will of course be, we can actually calculate that, we could have subtracted, but I will just calculate again. So 170 plus 30 and then 8 times 70, so that becomes 5.6 amps. So that is the current that's going this way. Now what we will do at this stage is, we know that this 8 amps which is coming from here will come back in this direction, so it will, the current in this branch is again 8 amps. So that current has come, that current is the addition of these two currents, and these two are parallel paths again, so we can again calculate what is the parts of 8 amps in these two branches, basically 20 ohms and 5 ohms. So once we can find this current, we know this current now, which is 2.4, and we can, if we can find this current, we can just apply KCL here to find this current basically, which is I naught. So again, if we say I20, that one, the current that's going through 20 ohms resistance downwards, that will be 20 plus 5, and we have 8 here because we are just seeing this current, and then it will be times 5 here because we want to find 20 amps, so that's 40 over 25, 1.6 amps. So that's there. And then if we want to find the other current I5, that will be 8 over 25 times 20, so that is 6.4 amps. So now we know a lot. We know this current is 1.6 amps and this is 6.4 amps. So I naught will be, we can find using applying KCL in either of these nodes. So first I will apply here maybe. So that will be 2.4 is coming here, and let's say it's divided between this branch and this branch, I naught and 1.6 20 ohms branch. So that will be basically I70 is equal to I naught plus I20. I70 is the current through, this is very clumsy, so maybe I will look here. I70 is the current downwards through 70 ohms resistance, and I20 is current downwards through downward in the downward direction through 20 ohms resistance. So I70 is equal to I0 plus I20, given that I0 is going in the other direction. So this one is, we know that 2.4 is this current downwards. I70 is 2.4. I will write it here, 2.4 I0 plus 1.6. So that gives us I0 is equal to 2.4 minus 1.6, which is 0.8 amps, or we can say 800 milliamps. So this is, we are getting by applying KCL at this node. Now we can try KCL at the other node, which maybe I will use a different color, maybe here. So this one again, the currents are, I0 is going in this direction, we have said that before, so we will just stick to that direction. We just want to see whether we get the same current. We should, of course. So I0 plus I30 will be equal to I5 if given the directions are like that, because 8 amps is in this direction, here in this direction. So of course we know that I5, which is this current, 6.4 is in this direction, and I30, which is 5.6 in that direction. So yeah, so I0 will be plus, I30 is 5.6 and this is 6.4, and again we get the same current, 6.4 minus 5.6, so that's 0.8 amps. So we get the same current again, and so I0 is 800 milliamps or 0.8 amps, whatever, and V0 will be I5 times 5 ohms, and I5 we have just written here 6.4, so 6.4 times 5, which is 32 volts, 32 volts. So that's V0.